I am Buzz Aldrin.
4, 3, 2, 1.
And I was the lunar module pilot on Apollo 11.
At 94, Buzz Aldrin, the iconic astronaut who famously walked on the moon during the historic Apollo 11 mission, has finally addressed long-standing questions and suspicions about Earth's celestial neighbor. As one of the few humans to have set foot on the lunar surface, Aldrin's reflections and revelations offer a unique and authoritative perspective on the moon's mysteries. With a lifetime of experience and insight, Aldrin's recent confirmation sheds new light on our understanding of the moon. What answers has he provided? And was the moon landing really staged? Join us as we uncover what Buzz Aldrin revealed, which confirms our suspicions about the moon. Buzz Aldrin's early life, role in moon exploration. Buzz Aldrin, the second man on the moon, was born on January 20th, 1930 in Glen Ridge, New Jersey, the son of a career military officer and an adventurous mother. His early fascination with flight was almost destined, as his father, Edwin Aldrin Sr., was an aviation pioneer, while his mother, Marion Moon, had a surname that seemed to foreshadow her son's extraordinary journey. Aldrin's path to the stars began with his education at the prestigious West Point Military Academy, where he graduated third in his class in 1951. Following graduation, he joined the United States Air Force and became a fighter pilot during the Korean War. During this time, he flew 66 combat missions and earned the Distinguished Flying Cross for his bravery and skill. This period shaped the discipline and determination that would later see him through the most challenging mission of his career. After the war, Aldrin pursued a doctorate in astronautics at the Massachusetts Institute of Technology. His groundbreaking thesis on manned orbital rendezvous earned him the nickname Dr. Rendezvous within NASA, an expertise that would prove crucial for the success of the Gemini and Apollo missions. In 1963, Aldrin was selected as part of NASA's third group of astronauts. His first spaceflight was as the pilot of Gemini 12 in 1966, where he performed the first successful spacewalk and demonstrated techniques that would be used in future missions. This mission solidified his reputation as a capable and innovative astronaut. On July 20, 1969, Aldrin made history as the lunar module pilot on Apollo 11. Alongside Neil Armstrong, he became one of the first humans to set foot on the moon. The iconic image of Aldrin standing on the lunar surface, saluting the American flag, is etched in history. His words, "beautiful view, magnificent desolation," captured the stark beauty and profound emptiness of the lunar landscape. Aldrin's contributions to space exploration did not end with Apollo 11. After returning from the moon, he continued to work with NASA and, into his old age, advocated for space missions and developed strategies for future exploration. He authored several books sharing his experiences and vision for humanity's future in space. Throughout his career, Aldrin faced personal challenges, including struggles with depression and alcoholism. However, his resilience and determination enabled him to overcome these obstacles and emerge as a vocal advocate for mental health awareness. Beyond his technical achievements, Aldrin became a cultural icon. His appearances on television, in movies, and as a character in video games made him a beloved figure outside the scientific community. His charismatic personality and unwavering passion for space exploration have inspired generations to look to the stars and dream of what lies beyond. At 94, as Aldrin sat before an audience, his legacy as a pioneer, a hero, and a living testament to the spirit of exploration was undeniable. He was ready to confirm what many had long suspected and share one more piece of his incredible journey. But before that, how did the space race even begin? The space race. The space race, a defining period in mid-20th century history, was marked by intense competition between the United States and the Soviet Union. This rivalry spurred remarkable advancements in space exploration and technology. The space race began on October 4, 1957, when the Soviet Union launched Sputnik 1, the first artificial satellite to orbit Earth. Weighing 83.6 kilograms, Sputnik 1's successful launch and transmission of radio pulses demonstrated the Soviet Union's superior technological capabilities and sparked a renewed focus on space exploration in the United States. In response, the U.S. established NASA on July 29, 1958, to accelerate its space efforts and regain its competitive edge. The Soviet Union continued to lead with significant milestones, including sending Yuri Gagarin into space on April 12, 1961, aboard Vostok 1. Gagarin's historic mission, which lasted 108 minutes and completed a full orbit around Earth, made him the first human in space. This achievement highlighted Soviet engineering prowess and represented a major psychological victory during the Cold War. The U.S. responded to these advancements with a bold commitment. On May 25, 1961, President John F. Kennedy pledged to land an American astronaut on the Moon and return them safely by the end of the 1960s. This ambitious goal led to the Apollo program designed to fulfill Kennedy's promise. The Apollo program's pinnacle came with Apollo 11 on July 20, 1969. Neil Armstrong and Buzz Aldrin achieved the historic feat of walking on the Moon, with Armstrong's iconic words, "That's one small step for man, one giant leap for mankind," capturing the significance of the moment. Aldrin's subsequent moonwalk further solidified their achievement in the annals of space exploration. The scientific and strategic importance of the Moon has been profound. Studying the Moon offers insights into planetary formation and the evolution of celestial bodies, including Earth. The Moon's surface preserves a record of cosmic events that predate those on Earth, providing invaluable data for understanding the early solar system. Furthermore, the Moon's proximity to Earth makes it a potential launch pad for future space missions, including those targeting Mars and other distant destinations. The Moon has also played a significant role in inspiring cultural and scientific endeavors. It has been a source of fascination and inspiration, appearing in myths, stories, and artworks throughout human history. The achievements of Apollo 11 and the subsequent exploration missions have continued to captivate the public imagination and drive interest in space exploration. Following the Apollo missions, the focus of lunar exploration shifted to long-term scientific research and practical applications. The development of technologies for sustainable lunar bases and resource utilization has been a major focus. For instance, the potential use of lunar resources, such as helium-3, offers the prospect of advancing nuclear fusion technology. Helium-3, a rare isotope on Earth but more abundant on the Moon, could become a crucial fuel for future fusion reactors, providing a sustainable energy source with reduced radioactive waste compared to traditional fission reactors. Recent technological advancements have furthered our understanding and capabilities in lunar exploration. For example, China's Chang'e 4 mission, which achieved a soft landing on the Moon on January 3, 2019, represents a significant milestone. This mission has provided valuable insights into the Moon's geology and surface conditions, contributing to our knowledge of lunar history and potential for future exploration. Looking ahead, global space powers are developing ambitious plans for lunar exploration. Proposals such as the Lunar Surface Electromagnetics Experiment Lander aim to revolutionize our understanding of the early universe by measuring electromagnetic waves from the Moon. Additionally, future missions will address challenges related to extreme lunar temperatures and radiation, with a focus on developing resilient spacecraft and habitats. Efficient heating and cooling systems will be essential to maintaining habitable conditions and supporting long-term exploration and potential lunar settlements. Overall, the space race and subsequent lunar missions have left a lasting legacy, advancing our understanding of space and inspiring future generations. The quest for exploration and scientific discovery continues to drive human ambition, with the Moon serving as a key stepping stone in our ongoing journey into the cosmos. And this raises the question, how did the Moon landing really happen? The historic Moon landing. Buzz Aldrin's role in the Gemini program solidified his importance in space exploration. Initially, a backup crew member for Gemini 10, Aldrin and Jim Lovell were promoted to the prime crew after the original crew tragically died in an air crash. This unexpected shift elevated Aldrin to a leadership role, allowing him to make significant contributions to space missions. During Gemini 12, launched on November 11, 1966, Aldrin achieved numerous milestones, including successful rendezvous and docking maneuvers and multiple extravehicular activities (EVAs), setting records and contributing to scientific objectives. This set the stage for his pivotal role as lunar module pilot in the Apollo 11 mission, marking a significant milestone in American space exploration. Aldrin's career reached its zenith during Apollo 11. On July 16, 1969, Apollo 11 made history with the first manned moon landing, a major human achievement. Aldrin, along with mission commander Neil Armstrong and command module pilot Michael Collins, embarked on this historic journey to the moon. Approximately 1 million people watched the Apollo 11 launch from various locations near Cape Canaveral, Florida, while it was broadcast live in 33 countries, with around 25 million Americans tuning in. This event was a landmark moment in space exploration. Apollo 11 launched at 13:32 Coordinated Universal Time from Launch Complex 39 Alpha at Kennedy Space Center and entered Earth's orbit 12 minutes later. After circling Earth 1.5 times, it began its journey to the moon using its S-4EB third-stage engine. By July 19th, Apollo 11 reached the moon and fired its engine to enter lunar orbit. During approximately 30 orbits, the crew identified their landing site in the Sea of Tranquility. The following day, Aldrin and Armstrong boarded the lunar module Eagle and prepared for their moon landing. At 17:44, the Eagle separated from Columbia, Apollo 11's main spacecraft. Thanks to Aldrin's expertise, the lunar module successfully navigated the complex stages of descending, landing, and ascending from the moon's surface. Aldrin's meticulous preparation and execution of extravehicular activities, that is, moonwalks, were crucial for conducting scientific experiments and collecting lunar samples. The journey to the moon's surface was nerve-wracking and pivotal to Apollo 11. As they neared the landing site, Armstrong noticed the area was littered with large rocks. Demonstrating exceptional piloting skills, he took manual control and guided the module to a safer location using a significant portion of its fuel. They landed on July 20th. Aldrin, a Presbyterian elder, performed a religious ceremony on the moon, a first in space exploration. After several hours, Armstrong became the first human to walk on the moon, declaring, "That's one small step for man, one giant leap for mankind." Aldrin joined him 19 minutes later, becoming the second person to walk on the moon. Upon stepping onto the lunar surface, he exclaimed, "What a breathtaking sight," capturing the moon's stark beauty. While exploring the lunar surface, Armstrong and Aldrin conducted experiments, gathered samples, and planted the American flag, symbolizing NASA's Apollo program's remarkable achievement and the dedication and innovation behind it. After setting up the lunar flag assembly, they conducted further experiments and spoke with President Nixon before preparing to leave. They also deployed scientific instruments like a seismometer and a laser reflector. As Armstrong explored a nearby crater, Aldrin collected lunar samples. Using a pulley, they carefully lifted lunar material and film boxes to the hatch. After transferring everything to the lunar module's life support system, they disposed of unnecessary equipment, closed the hatch, and rested. They then took off in Eagle's ascent stage to rendezvous with Collins aboard Columbia in lunar orbit. Once they reunited with Collins, Columbia began its return journey, splashing down in the Pacific Ocean east of Wake Island on July 24th. The mission concluded successfully, lasting 195 hours, 18 minutes, and 35 seconds. Life after Apollo 11. Following the success that elevated him from astronaut to legend, Buzz Aldrin remained deeply involved in space and aviation. As the commandant of the U.S. Air Force Test Pilot School, he significantly influenced a new generation of pilots and astronauts. Although Aldrin concluded his tenure at NASA and the Air Force in 1971, his commitment to space exploration persisted. During his time at NASA, he accumulated a notable total of 289 hours and 53 minutes in space, including 7 hours and 52 minutes of extravehicular activity. In his post-NASA career, Aldrin focused on advancing human space exploration, particularly his goal of sending humans to Mars. He developed the Aldrin Cycler, a spacecraft trajectory concept designed to improve travel efficiency between Earth and Mars. This innovative method aims to reduce travel time and fuel consumption, making Martian expeditions more feasible. Aldrin's advocacy extended to space policy and education, where he worked to inspire and support the next generation of scientists, engineers, and astronauts. Aldrin founded the ShareSpace Foundation, an organization dedicated to promoting STEM education. Through this foundation, he has provided students with practical experiences and resources to foster their interest in space and science. Additionally, Aldrin has authored several books, including his autobiography, Magnificent Desolation, and children's books aimed at inspiring young readers to dream of space exploration. His writings offer insights into his experiences and a vision for the future of space travel, encouraging readers to broaden their horizons and consider humanity's potential in the solar system. Aldrin has also shared his observations on the Moon, including the enigmatic far side, which he described as a breathtakingly desolate landscape. His insights have contributed to our understanding of the Moon's geology and its potential for future exploration. Following the historic Moon landing, Aldrin maintained a certain reticence about his lunar experiences, which sparked public curiosity and speculation. The mystery surrounding his silence led to widespread interest in the emotional and psychological effects of his moonwalk, as well as his reflections on the profound isolation and achievement of the experience. This reticence accentuated the deeply personal aspects of space exploration and highlighted how astronauts grapple with the vastness of space and their place within it. In recent years, Aldrin has begun to share more about his moon landing experiences and the emotional and psychological challenges he faced upon returning to Earth. He has openly discussed the feelings of loneliness and the difficulty of readjusting to normal life after such a monumental accomplishment. Onto the kicker for today, what has Aldrin resealed? Does it confirm the theory that the moon landing was faked? Conspiracy theories and the big revelation. Buzz Aldrin's recent interview with Conan O'Brien sparked a wave of social media activity when he discussed the moon landing. In the interview, Aldrin mentioned that broadcasters used animations during their moon landing coverage, a comment that conspiracy theorists seized upon as proof that the landing was faked. This skepticism has persisted for many years, driven by various conspiracy theories, such as the lack of stars in the lunar surface photos, which skeptics claim should be visible without atmospheric interference. Additionally, anomalies like the fluttering flag and inconsistent shadows in the photographs have fueled these suspicions. However, the controversy arises from a misunderstanding of Aldrin's explanation. He was merely describing the media techniques of the time. In the 1960s, technological limitations and the challenges of live broadcasting from space meant that television coverage of the moon landing involved a combination of real footage and animations. These animations were used to help viewers better understand the mission, as it was difficult to convey the full scope of the event with the available technology. Aldrin never suggested that the moon landing was a hoax. In 2009, NASA released digitally remastered footage of the moon landing, offering clearer images of this historic event. Furthermore, institutions like the Smithsonian National Air and Space Museum and the National Science and Media Museum have detailed the technical and logistical challenges of recording and broadcasting the moon landing. Margaret Whitekamp, the chair of the Space History Department at the Smithsonian, explained that the limitations of 1960s technology necessitated the use of animations to convey the story of the moon landing to the public. Reports, photographs, and expert analyses confirm the reality of the moon landing, highlighting its significance in space exploration. Despite overwhelming evidence supporting the authenticity of the Apollo missions, conspiracy theories continue to persist. Critics often point to the absence of stars in Apollo mission photos as evidence of a studio setup. However, these photos were taken during the lunar daytime, when the bright sunlight made the stars invisible to the cameras. Skeptics also mention the flag's fluttering, which can be attributed to the moon's lack of atmosphere and weak gravity, causing unusual visual effects. The flag's apparent fluttering is due to its horizontal rod and the absence of air resistance. Another compelling argument involves the Van Allen radiation belts, with critics claiming that passing through these belts would expose astronauts to lethal radiation. However, careful planning and spacecraft design ensured safe traversal of the belts, with radiation exposure well within acceptable limits. Modern technologies, such as the Lunar Reconnaissance Orbiter, have provided high-resolution images of the landing sites, confirming the presence of artifacts left by the Apollo missions. Additionally, the Lunar Laser-Ranging Retroreflector Array, installed on the Moon by Armstrong and Aldrin, still enables precise measurements of the Moon's distance from Earth, serving as irrefutable proof of human presence on the lunar surface. In another instance, social media claimed that Buzz Aldrin witnessed aliens during the Apollo 11 mission. Aldrin did describe seeing an unidentified object outside the spacecraft, but he clarified in a 2014 Reddit Ask Me Anything session that it was likely sunlight reflecting off panels from the spacecraft, not evidence of extraterrestrial activity. Some even claimed that Aldrin underwent a lie detector test about this sighting, but NASA confirmed that these claims were taken out of context. The roots of moon landing conspiracy theories can be traced back to Bill Kaysing's 1976 book, We Never Went to the Moon, America's $30 billion Swindle. This book was released during a time of political distrust, and these theories have resurfaced with the advent of the Internet. In 2002, Aldrin famously punched conspiracy filmmaker Bart Sibrel, who accused him of faking the moon landing. Despite the persistence of these theories, it is more productive to celebrate the achievements of the Apollo program and humanity's remarkable accomplishments in space exploration. To tackle these conspiracy theories head-on, one must first comprehend the assertions they make. For example, the non-parallel shadows in Apollo photos can be attributed to the lunar surface's topography and the angle of the sun. The theory that filmmaker Stanley Kubrick staged the moon landing is also implausible, given the technological limitations of the time. The continued interest in lunar exploration is evident in NASA's Artemis program and future plans for space exploration. A wealth of evidence supports the reality of the Apollo moon landings, including moon rocks, lunar dust, laser reflectors, and images from the Lunar Reconnaissance Orbiter. The Apollo missions represent a pinnacle of human ingenuity and exploration, demonstrating our capacity to reach beyond Earth. The space legend has shared his insights into the before, during, and after the moon landing, including the far side. But what exactly did he see on this side of the moon? The far side of the moon. Reflecting on his Apollo mission experiences, Buzz Aldrin recounted his views of the moon's far side. Although he never set foot on this uncharted area, he, like his fellow astronauts, saw its majestic vista from orbit. Aldrin described the far side as magnificent desolation, a stark, barren landscape. Despite being called the dark side, it receives sunlight just like the near side. This term arises from the moon's synchronous rotation, which keeps the same side facing Earth, rendering the far side invisible from our planet. Aldrin highlighted that the far side differs significantly from the near side. It lacks the expansive dark plains called Maria found on the near side, and instead features rugged terrain with countless impact craters and towering mountain ranges. Extreme temperature fluctuations characterize the far side, reaching scorching highs of 127 degrees Celsius during the lunar day and plummeting to minus 173 degrees Celsius during the lunar night. These extremes occur due to the moon's lack of atmosphere, akin to Mercury. One notable feature on the far side is the South Pole Aitken Basin, one of the largest and oldest impact basins, spanning about 1,600 kilometers in diameter. Only 18% of the far side is visible from Earth due to libration, a slight rocking motion of the moon. The remaining 82% remained hidden until October 1959, when the Soviet probe Luna 3 captured the first images. Further missions, including Zond 3 in 1965, revealed more details, leading to the Atlas of the Far Side of the Moon by the USSR Academy of Sciences. NASA's Ranger 4 probe reached the far side in April 1962, marking the first American exploration, though it did not return scientific data. The American Lunar Orbiter program from 1966 to 1967 mapped the far side, unveiling previously unknown terrain. Human eyes first saw the far side during the Apollo 8 mission in December 1968. Astronaut William Anders described it as a sprawling sandpile with irregular bumps and hollows. Despite occasional communication blackouts when spacecraft were behind the moon, subsequent Apollo missions and lunar probes continued exploration. Past proposals included landing on the far side, such as one by geologist astronaut Harrison Schmitt for Apollo 17, but logistical and budget issues prevented it. Recent advances, like China's Queqiao relay satellite launch in 2018, have improved communication with lunar missions on the far side. On January 3, 2019, China's Chang'e 4 spacecraft achieved the first soft landing, conducting groundbreaking research with advanced instruments. This mission offered new insights into the far side's geological evolution. Leading astronomers now propose installing a large radio telescope on the far side to avoid Earth's radio interference, enhancing astronomical observations. The far side's natural formations, like bowl-shaped craters, offer promising locations for these telescopes. Overcoming challenges such as lunar dust contamination and solar flares is crucial for maximizing their potential. Looking ahead, global space powers have ambitious lunar exploration plans. Proposals like the Lunar Surface Electromagnetics Experiment Lander could revolutionize our understanding by measuring early universe electromagnetic waves. The far side also offers opportunities for resource exploration and potential lunar settlements, with significant helium-3 concentrations for fusion reactors. Future lunar missions will face challenges like extreme temperature differentials, requiring resilient spacecraft and habitats. Efficient heating and cooling systems will be vital for sustaining habitable conditions. The discovery of thorium on the far side is promising for nuclear fusion reactors. Thorium-based fusion technology could provide sustainable energy for lunar missions and settlements, with reduced radioactive waste compared to uranium fission reactors. Although still developing, thorium-based fusion holds great potential. Unlike fission, which splits atoms, fusion combines atomic nuclei, releasing much greater energy. Advancing thorium-based fusion research could lead to energy independence for lunar endeavors, paving the way for sustainable exploration and reducing reliance on Earth-bound resources. Buzz Aldrin's achievements have no doubt left marks on the sands of time. He goes on to tell of his experiences, and his legacy stands solid. What does he tell us about the future of moon exploration, reflections, and legacy? Buzz Aldrin achieved feats that many could only dream of, yet he always stayed humble about his contributions to space exploration. He often remarked on his incredible fortune and the significance of being part of something far larger than himself, emphasizing that the journey to the moon was a collective endeavor of all humanity. Aldrin frequently reflects on the profound impact of the Apollo 11 mission. He recognizes that their historic moon landing inspired generations and ignited a global enthusiasm for space exploration. Standing on the lunar surface and looking back at Earth, he felt a deep connection to everyone back home, which highlighted the smallness of our planet and the interconnectedness of all people. This perspective influenced his views on the necessity of international cooperation and a united effort in space exploration. Aldrin also underscores the symbolic importance of their mission. He believes that the Apollo 11 mission demonstrated what humans could achieve when united by a common goal. The moon landing was not merely about science and technology, it was a testament to human spirit and perseverance. It proved that no dream is too big if pursued with courage. Looking toward the future of space exploration, Aldrin is both optimistic and forward-thinking. He strongly supports missions to Mars and sees the colonization of the Red Planet as humanity's next significant step. For him, the question is not whether we will go to Mars, but when. He is enthusiastic about the new horizons for exploration and discovery that such missions will bring. He is particularly excited about engaging young people in the quest for space through his Share Space Foundation. Aldrin works diligently to promote STEM education and inspire the next generation of scientists, engineers, and astronauts. He believes that today's young minds will become tomorrow's pioneers, and that we must encourage their big dreams and provide the necessary tools to make those dreams a reality. Aldrin's legacy is broad and includes his technical contributions, advocacy for space exploration, and role as an inspirational figure. His development of orbital rendezvous techniques was crucial for the success of the Gemini and Apollo programs. His support for human missions to Mars and beyond continues to influence space policy and inspire future missions. Yet perhaps his most lasting impact is the inspiration he provides to countless individuals worldwide. The image of Aldrin standing on the moon and saluting the American flag remains a powerful symbol of human achievement. His words and actions motivate people to reach for the stars, push boundaries, and continue exploring. As Aldrin reflects on his life, he is deeply aware of the historical significance of his journey. He sees human achievements as part of a continuum, with current accomplishments building on the work of those who came before and laying the foundation for those who will follow. This sense of continuity and progress is central to his vision for the future. Aldrin's reflections also reveal a profound sense of responsibility. He believes that space exploration is not just about discovering new worlds, but also about ensuring humanity's survival and prosperity. He argues that the challenges we face on Earth, such as resource depletion, overpopulation, and climate change, can find solutions through space exploration. By pushing the boundaries of our knowledge and capabilities, we can work towards a better future for everyone. In his later years, Buzz Aldrin remains a steadfast advocate for space exploration. His reflections and insights continue to inspire and motivate those who seek to follow in his footsteps. As we approach new frontiers in space, we do so with the understanding that we are part of the continuum he often mentioned. We build on past achievements and pave the way for future generations. Ultimately, Buzz Aldrin's story is about both the past and the future. It shows the boundless potential of human ingenuity and the unyielding desire to explore and understand the universe. As we look to the stars, we remember the incredible journey that brought us here and the pioneers like Buzz Aldrin who made it possible. His legacy will continue to inspire and guide scientists as they embark on the next great adventure in space exploration. What do you think about Buzz Aldrin's revelations? Let us know in the comments below. Thank you for watching. Don't forget to like and subscribe to see more videos. While you're still here, click the video on your screen for another interesting content.